Hi, in this video we are going to talk about operator overloading in C++. We have talked about operators, we have used them for basic data types like int, char, float, etc. Let us now understand how can we use for our own data types. For example, if I have a complex class which represents a complex number and I want to use the plus sign to add two complex numbers like the normal numbers are added. So if we want to use operators for our own classes, we can use operator overloading. C++ provides this flexibility. This is not there in many other programming languages, like Java does not support operator overloading. You cannot write operator functions for your own classes in Java. But in C++, you can write a function which is called when an operator is used on your own class. Let's take a look at this example. I have a complex class here which has real and imaginary parts. Then there is a constructor that initializes real as r, imaginary as I, right? So I've used initializer list for this. Then this is the operator overloading function, right? Please note that operator overloading is different from function overloading. In function overloading, we can use the same function name for multiple purposes. Here, meaning is we use operators for our own data types. So this function plus is called here when you use C1 plus C2. So we created two complex class objects, C1 and C2. And when we did C1 plus C2, this acts as a function call C1 dot operator plus and C2. This is how this line is treated internally by the compiler. This becomes a function calls. And this function is executed. What are we doing inside this function? We create a result object. We assign result.real equal to current object's real, which is C1.real, and the past object.real, which is C2 here. And similarly, result.imaginary is assigned current.imaginary plus object.imaginary. I can also write this arrow real, this arrow imaginary. Finally, we return result and we get the addition in C3. So what do we get as an output when we run this program? We'll get 10 plus 2, 12 plus I, 4 plus 9, 4 plus 5, 9. Please note that this is one way of doing operator overloading where I have defined the operator function inside the class. We can also make it a global function that takes two complex class objects, C1 and C2, does their sum and returns the resultant complex number. So if you have defined plus function globally rather than inside the class, that also works. And that function will also be called if you do C1 plus C2. So there are two ways to overload operators, either making a function inside the class or making a global function. Let us now talk more about operator overloading. Let's talk about this first point. What is the use of it? Imagine that you have a complex class number which has many complex expressions which involve many mathematical computations. For example, you want to find out the value of C4, which is C1 plus C2 into C3, right? So if you do not overload operators, you will write some functions. You will do something like C4 equal to C1 dot add, C2 dot multiply, C3. This is how you will do it, right? This makes the code less readable. Because you are working on some mathematical class, it makes more sense to write something like this. So if you have overloaded operators, plus and multiply, then you can write this expression, which is more readable for the users. Let's now talk about the second point. Can we write anything inside the operator function? Yes, you can write anything. You can write cout statements, you can write cin statements, but should you be writing these things? The purpose of operator overloading is to make the code more readable. So if somebody is using plus operator, the meaning of the plus operator, the use of plus operator should be same as expected. If we are doing anything extra or anything less inside this operator function, then it's not a good operator function. The simple rule to judge an operator function, if somebody has to look inside your function to understand what this operator function is actually doing, then it's not a good operator function because it's doing something unexpected. The reader of the code has to go inside and see what is it actually doing. What about precedence, associativity, and arity of the operators? Arity means number of operands it takes. So when we overload operators, precedence, associativity, and arity, these things do not change. So the plus operator, star operator here, they'll work the same way. This will be executed first because this is higher precedence, and this will take 2 parameters because it's a multiply operator. Then plus will be executed. Next point, can we overload all operators? No, we cannot overload all the operators. We cannot overload, for example, dot, scope resolution operator, conditional operator, and size of operators. These are not allowed by C++ standard to be overloaded. Except these operators, we can overload almost every operator. Let us now talk about assignment operator. If you do not write your own assignment operator, then compiler creates a default assignment operator for you. Why does compiler need to create this assignment operator for you? To make sure that lines like these work always. You can create two objects of a class test, T1 and T2 are the two objects, and then you can do T1 equal to T2. So this line would not work if there is no assignment operator. Here, assignment operator function is called. So if you do not write your own assignment operator function, compiler by default creates an assignment operator function that does member by member copy of members of T2 to members of T1. Now the question arises, when do we need to write our own assignment operator? When is it needed? So the answer is simple. It's same as copy constructor rule. The default assignment operator, it does shallow copy. If your class has dynamically allocated memory or it has pointers which point to some dynamically allocated memory, then we should be doing deep copy and we should be writing our own assignment operator that allocates a new dynamic memory and copies the data of the other class. Same thing we did in the copy constructor. So the general rule is, if your class has constructor that dynamically allocates memory and you have a pointer inside the class that points to this dynamically allocated memory, then you should write destructor to make sure that there is no memory leak. You should write copy constructor to make sure that shallow copy does not happen, and you should write your own assignment operator. If you do not write your own assignment operator, then shallow copy will happen. And the same problem, if you create an object of one class, say T1 and T2 have some dynamically allocated memory, and you assign using shallow copy, you say T1 equal to T2. So what will happen? If you make any change in T2, changes would reflect in T1 also, like the example we did in the copy constructor. In this video, we talked about operator overloading. Operator overloading allows you to overload operators for your own defined classes. We discussed an example of complex numbers. Operator overloading can be implemented by making a member function or by making a global function. One important fact is, assignment operator is by default implemented by compiler for every class. If we have dynamically allocated memory in our class, then we should write our own assignment operator function.